We look at soil as the substrate in which we grow our plants. But it's much more than that. It is a teeming ecosystem full of life and is an essential part of every agricultural endeavor. Agriculture has been the backbone of every society since the beginning of human civilization. It provides food for us and the animals we rely on. Without it, life as we know it is impossible. But what is soil? What is it made of? And how do we take care of it? Every soil has two essential components: the inorganic part, composed of degraded indigenous rocks, and the organic part, composed of decayed living organisms. Much of the properties of the soil come from its parent rock, such as its mineral content, acidity, and buffering capacity. If the rock is rich in iron, the soil will also tend to be iron-rich. The size of the rock particles that form the soil is essential for how the soil interacts with organic matter and the mineral nutrients we need to apply as fertilizers. Generally, we split soil particles into three fractions depending on their size: clay, which is the smallest, silt, intermediate size, and sand, the largest of them all. The ratios of these three size fractions in our soil make up its texture. Every soil composition has its strengths and weaknesses in regard to agriculture. Small particle size or clay soils can be very good for agriculture in the right conditions. For example, they can store high quantities of nutrients and water. On the other hand, cut the rainfall for a while and you might end up with a slab of impenetrable mass, which prevents water flow and plants from growing their roots. Work with heavy machinery can lead to the formation of things like a plowing pan, which can also stop the water flow and root growth. Sandy soils can be excellent for vegetables because they allow easier root growth and prevent soil compaction. On the other hand, they are generally poorer in nutrients and are prone to leaching under rainfall. This means that a lot of the nutrients in the soil can be washed away because the sandy soil is incapable of holding on to them. No matter if you're a professional farmer or a hobbyist growing a couple of tomato plants in their backyard, you'd better consider what your plants like best. Now let's take a look at the pH of the soil. Many plants of agricultural importance prefer pH ranges that are neutral to slightly acidic. Phosphorus, for example, is mostly available for plant uptake at a pH of around 6. In more acidic soils, phosphorus can bind to iron or aluminum and become unavailable, while at higher pH, it can bind to calcium and become unavailable. Therefore, we must carefully maintain the soil pH at levels where our plants can take up nutrients at full capacity. Application of mineral nitrogen fertilizers generally leads to reduction of the soil pH over time, while liming is generally used to counter this effect. However, when we try to plan our pH management, we must take into account some additional soil properties like buffering capacity and cation exchange capacity, but we'll cover this in another video. The organic fraction is where most of the soil magic happens. Its importance can be illustrated best with agricultural practices in tropical regions. Large quantities of lush forest and vegetation are cleaned to make space for crops like soybean and maize. However, the yield of those crops rapidly deteriorates after several years of intense agriculture, and the field must be left to be colonized again by forest so that the soil can recover. This is mostly due to the rapid loss of large quantities of organic matter. When the forest grows, plants shed their leaves and dead trunks while animals leave their waste in their bodies to decay and decompose. The decomposing action of fungi, bacteria, and soil fauna transforms them into the nutrient-rich organic soil that forms the foundation of the tropical ecosystem. Furthermore, most plants form symbiotic relationships with soil microorganisms. For example, leguminous plants form symbiosis with bacteria that help them get their much-needed nitrogen from the atmosphere in exchange for carbohydrates. On the other hand, soil fungi colonize the plant roots, trading difficult-to-reach nutrients, such as phosphorus, for their much-needed carbohydrates. Additionally, a healthy soil rich in beneficial microorganisms will be more resistant to colonization by harmful bacteria and fungi. The native organisms will basically defend their land against invaders to death. The organic matter improves the soil and prepares it for life. A healthy, living soil can help sustain a healthy and prosperous agriculture. The addition of organic matter to an agricultural system can come from many places. For example, crop rotation, where the whole plants or parts of them are left on the field and mulched, will help maintain a healthy amount of organic material. The addition of animal waste, such as urine and manure, will enrich the soil in nutrients like nitrogen and phosphorus while adding organic material to the soil ecosystem. Life and death are dancing to the rhythms of time, and none of them can exist without the other. If one lets go, their eternal dance will end. A healthy ecosystem with a healthy soil is built on the dead bodies of the organisms that live in it and through it, and we must respect that balance in order to thrive in unison with our environment. Worldwide soil deterioration is one of the main challenges of the 21st century. A healthy diet comes from the plants and animals we care for, while healthy agriculture grows together with its soil. Producing sufficient food for our ever-growing population is dependent on maintaining our soil resources.